All right, so let's take a look on the top of page 20. So look here. First of all, the directions tell you what to do, but it's not always going to be like that. It's just going to say evaluate. So the first key here is you see d dx, meaning take the derivative with respect to x of integral notation. So you told me that those two are going to cancel each other out, but you have to make some substitutions. So right now my function is in terms of t. So that means my upper limit, which is a variable, is going to go in for t right here. What is my answer? What do you think the answer is? Yes, cosine x to the fourth. You're done. Now, this is technically times the derivative of this, which is 1, but do we, whenever it's times 1, don't we just kind of move on? I'm going to show you when it's not, I promise. Okay, questions on A. Okay, take a look at B. What tells you, other than the directions, that you can use FTC Part 2? Other than the directions, smarty pants. Okay, constant in the variable and the bounds. Okay, so I got this and this, which I'm just highlighting. What else? One more thing. The ddx with the integral, right? And then these two variables. So one small thing that is kind of messing me up is the format. So how do I fix this? I asked you about it already. Take out a negative and flip your bounds. So what we have is ddx, the opposite of the integral from 0 to x of the natural log of t dt. This must go along with your answer. So what is my answer? Negative ln of x times the derivative of x, which in this case is just 1. Okay? Questions?
Why do you do the times the derivative of x?
I'm going to show you in just a second. Because if I don't keep saying that, when you have an upper bound, look at this upper bound right here. What's different about this upper bound in C that A, B, and your example, so it's not just x. It's x to a power. I mean, it could be 2x cubed. It could be a polynomial, 6x squared minus 3x plus 1. Okay, still x, right? Okay, so this is what we need to look at. Do I have my ddx? Check. Do I have my integral? Check. Upper, lower bounds. One's a constant, one's a variable in terms of x. Check, check, check. Got everything, right? The only thing that's different now is that my upper bound variable is not just a plain old x, so we're going to deal with that. So the first thing that I'm allowed to do is take out the t in the sine cubed t and put in my x squared. Okay, so I've got sine cubed x squared times. So Elena asked me, why do you keep doing times 1? Well, what's the derivative of x? 1. What's the derivative of x squared? Okay, so you have to multiply by the derivative of that upper bound variable. That's your answer. You're done. Or you can put the 2x in front. It doesn't matter where it goes. Questions? Okay? All right. So before I go into this last problem, does anyone have any questions they want to ask me? Yep.
I presume this only works with variables.
What do you mean? The FTC? Part 2?
Yeah.
Yes.
Right.
But you can have, like what I said before, you can have a polynomial in there with variables, like 2x cubed minus 6x plus 3. It's still all in terms of x. But what you have to look at is the function that is to the right of the integral is anything other than x, like sine of t dt. Typically, I would say 99% of the time, it's going to be sine of t dt. Take a look here. In our example 5, you have f of x is equal to the integral from 1 to x of t minus 1 over t squared minus 9 dt. So there's your integral. Even though you don't see the ddx, they're saying that the original function is going to be equal to this. The fact that this is in terms of t and your upper bound is x leads you to the fundamental theorem of calculus part 2, based on the pattern. Okay? So if we know that this is all going to go away, we're saying that the original function, based on this notation, capital F of x, okay, is going to be equal to the derivative of the integral. So once I make this substitution, what am I going to have? Do I have the derivative? What do I have? Well, this is saying, yes, but because I haven't taken the derivative of it, I still have f prime. That's what I have. That's to the right, because I don't have the d dx, so I don't have that there. But I can still use a fundamental theorem of calculus, okay, because of this t and the upper bound being a variable. So what I have right here, once I plug in my x, is I have f prime. And why is this important? This is actually going to take us back to when we were talking about mins and maxes. Folks, you need to know this. It says find the value of x where f attains its maximum value. How do we find max and mins? We take the derivative, but wait, if I do what I just talked about with the fundamental theorem of calculus part 2, I will already have the derivative. Okay, so I need to make my substitution. So right here, what I'm going to say is that f prime of x is equal to, you're going to make that substitution. It's x minus 1 over x squared minus 9. Okay, so I'm going to go right here. For a, f prime of x is equal to x minus 1 over x squared, minus 9. Now, I have a rational function. How do I, what do I do to find mins and maxes? What am I looking at? Oh, critical numbers. How do I find critical numbers here? Yep, set the numerator and denominator equal to 0. So that means I have critical numbers where x is equal to what? 1, 3, negative 3. Can you tell me something about these two specifically? What are they? Think graphically if you had to graph the derivative. I'm hearing all kinds of stuff.
The areas.
Yeah, but I'm just graphing it, just like you had to graph in Algebra 2 or whatever. I heard it. What? Yes, I've got 2 vertical asymptotes. That's what I just need you to think. Okay? Bah. And the reason why is because we talked about this during that unit. Can vertical asymptotes be mins and maxes? No, they cannot. Because nothing's going to happen there, right? It's undefined at that value specifically. So it's important that you know that these are vertical asymptotes. All right, so here's my number line. You guys told me negative 3, positive 1, and positive 3. If I were to write this all factored out, aren't those degrees all 1? Well, first of all, this is squared, so tell me about this value in the bottom. What's the only thing that's going to make it negative? Tell me some values.
3.
Anything greater than or less than 3, right?
3 and 3.
Okay, so do you remember when we talked about multiplicity?
Yeah.
Kind of, sort of. If I write these as factors, this is x minus 1, x plus 3, x minus 3. Each factor has a degree of what? 1. Odd multiplicity. So what can I start with over here? Positive. What if you're not sure? What do? Plug in. Yep. So if this is 4 minus 1, it's positive here. 16 minus 9, positive. What do you think goes here? I heard it, negative. Yeah, because 2 minus 1 is positive, 4 minus 9 is negative. What do you think goes here?
Negative.
What?
Negative.
It's positive. It alternates. It's not a, remember, if it was a degree of 2 at that, this right here, this would repeat. So if I put in 0, 0 minus 1, negative. 0 squared minus 9, it's a negative over a negative, which is positive. What do you think this is? Negative. Okay? So what this means about f of x, decreasing, increasing, decreasing, increasing. Where do I have a maximum value? Okay, so what you would say is x equals 1 is a what? Relative max. Why? F prime changes from positive to negative. That's right. So this is my justification. You have to make sure you read the directions on a test quiz wherever. Okay, part B. Find the intervals over which f is decreasing. Oh my gosh. Don't we already have that information? Look at that. Decreasing from where to where? F is decreasing. I heard it. From where? Negative infinity to, is negative 3 included? Why? What is it? To negative 3, okay? And then from where to where? 1 to 3. Can I include 1? But 3 I cannot, yes. And if I had to justify, what do you say? This is a nice, easy, quick one. F prime is, yeah, less than 0, right? It's negative. Okay, let's talk about C. Okay. Find the open intervals over which F is concave up. Yikes. Okay. So let's talk about this. We need to take the second derivative, F double prime of X. So I'm looking at this right here. So it's F prime times G, so isn't it just this? X squared minus 9 minus FG prime. Is this 2x times x minus 1 over x squared minus 9 squared? Tell me about the denominator. I need to simplify the numerator, but tell me about the denominator if I plug in or look for critical numbers. Yeah, won't this always be positive in the denominator? Why? Because you're squaring the whole thing. Okay, so when I simplify this, this is x squared minus 9 minus 2x squared plus 2x. Okay, so you have the opposite of x squared minus 2x plus 9, and this is all over x squared minus 9 squared. So I'm going to save you a little bit of time because I have a few things that we need to take care of. First of all, 2 factors of 9 that add up to negative 2 we know we don't have. So if I use the discriminant, you guys know where that's located underneath the radical and the quadratic, it comes out to be negative. So tell me about your answers from the numerator. Yeah, they're imaginary. So I don't have any critical numbers from the top. So what are my critical numbers from the bottom? X is equal to plus or minus 3. Okay, so let's take a look here. If we know that the bottom will always be positive because it's squared, what's going to happen to the numerator? It's always going to be negative. It is. Because you've got, let's just take a look. So if you've got negative 3 and positive 3, if I plug in 0, this is the easiest one, 0 minus 0, 9, opposite. So that means in here we're negative. What if I put in, I don't know, negative 4? 16 plus, because it's going to be negative times a negative, plus, then you're going to take the opposite of that. So this is negative. Plug in 4. This is 16 minus 8, still positive, right? 16 minus 8 plus 9, take the opposite, negative. So the question was, find open intervals over which f is concave up. What are you going to tell me? Yeah. F of x is never concave up because f double prime is always negative. Okay. Let's see. D and E, they're going to be quick. D is f prime of 0. E is f double prime of 0. So I'm just writing it out. That's an E, sorry. Whoa. F prime of 0, plug in 0, what do you get? Look at F, it's right here. There's F prime, plug in 0. So the answer is 1/9, right? Okay, let's plug in 0 to F double prime, excuse me. So this is, oh, we did it already. 0, 0, so this is negative 9, right? Negative 9 over 81. So is that negative 1/9? Okay, that's just algebra, right? Okay. Last piece. We want to find f of negative 1 and f of 3, and we're actually going to use the calculator for this. So this is going to be f. F of negative 1 and then f of 3. So this is what we're going to do first. We are going to put our function that we were given, okay, from the very beginning into y equals. So my sine of x is going to go away, and I'm going to plug in x minus 1. I'm getting it from right up here. Okay? Because this is the derivative. So we've got x minus 1, and this is over x squared minus 9. Okay? And now I'm going to go back into the home screen. So, I need you guys to pay close attention. If we want to find f of negative 1, isn't this the original function? That means if this is the derivative, right, don't I have to integrate this? Yes? Okay. So look it. If you look here, this goes from 1 to x. They gave us an x value. Okay? So what they want is, they want the integral, I'm just going to fill it in exactly as is. 1 to negative 1, and I'm just going to write of f, let's say f prime of x dx, because I don't want to write the whole thing out, because I'm lazy. Sorry. It's already in my calculator. We have it at the top, and we put it in the calculator. So two things can happen here. If I had to do this algebraically, what do I have to do to this? I have to flip. Let's see if the calculator will do it for us. So we're going to go into alpha window, grab option 4. We're going to go from 1 to negative 1. Where did I put my function?
1.
That's right. Okay, dx. Ready? Oh my gosh. It does it for you. You don't have to negate it. It'll do it for you. Isn't that crazy? This calculator is like the best. Okay, so my answer is negative 0.2310. That's the area under the curve, okay, from negative 1 to 1, technically. Now, they want f of 3. So think back to what I just did. I want the integral. I'm going back to what I have up top here. It goes from 1 to x. Where does this 3 go? Yeah, it's my upper bound. So it goes from 1. This was in the setup at the very beginning of the problem. X, which is this right here, to 3. So f prime of x dx. Okay, so now I'm just going to be a little bit lazy. Watch this. Second entry. I don't have to retype everything. It recalls what you had. So I'm going to change this negative 1 to a 3. Ready? A 100 years. 100 years. 100 years.
How come it takes so long?
Oh, wait for it. Wait for it. Oh my gosh, I'm waiting for it. Come on. Ah! What does that mean?
It means that it's undefined.
It tells you, right? You cannot divide by 0. So guess what? It's not possible. Why? Look at your function. Vertical asymptotes. Most likely you had them in your original. Okay, so you can't divide by 0, so this is not possible. Okay, the function is not defined. You don't have to say why because you don't have the exact reason. You just say it's not defined at x equals 3. Okay? Questions? So my suggestion to you is make sure, I got you, make sure that you go back and look at this problem again.